Welcome to this explainer, where we decode the principal examiner's mindset to help you completely master hexadecimal representation in your Cambridge computer science exams. Think of exam strategy like being a master chef. To succeed, you need the perfect recipe. Your theoretical knowledge, those are your raw ingredients. Your analysis, that's the cooking process. And your evaluation, that is the final plating. Today, we are focusing on syllabus codes 0417, 0478, 2210, and 9618. If you've ever felt the absolute agony of knowing the material inside out, but still dropping easy marks on the actual exam paper, you are in exactly the right place. We are going to transform how you approach this topic, moving entirely away from basic memorization straight into top-tier, examiner-approved application.
Okay, let's dive right into the challenge. We have to start with this crucial question. What digital problem does hexadecimal actually solve? To understand why this matters, let's look at two typical computer science students, Alex and Sam. Now, Alex is what I call the human textbook. Alex overloads answers with raw computer science facts, but offers absolutely zero analysis. Faced with a past paper question about why hexadecimal is used for MAC addresses, Alex writes, hexadecimal is base 16, it uses numbers 0 to 9 and letters A to F, and it takes up less space. It's just raw ingredients dumped on a plate. Then we have Sam. Sam rushes. Sam completely misses the command word requirements. Sam just writes, it's easier for humans to read. Look at their flawed answers side by side with those brutal red pen marks. Memorizing isolated hexadecimal facts without understanding their real-world purpose, without actually cooking the ingredients, is the quickest way to drop marks. The examiner wants to know if you understand what data is involved, what process is taking place, and what the practical consequence is for user.
To fix the mistakes that Alex and Sam are making, here is our precise blueprint for today's session. We'll start by unpacking the contextual trap. Then we will walk through the method mark strategy. Third, we'll look at direct principal examiner warnings. And finally, we'll build a reliable memory structure. Let's jump into section 1, the contextual trap. This is all about why you absolutely must go beyond short labels and simple definitions. To secure the highest marks, you must transition from simply memorizing generic facts to applying precise terminology within realistic contexts. Let me reveal the strategy the top students use. It all starts with animated breakdown of command words. If the question says state, you give a fact. If it says explain, you must give the how and the why. This is where we introduce the Peel framework: point, evidence, explanation, link. Top students structure their computer science answers using Peel. Your point is your main idea. Your evidence is the technical fact, like hexadecimal uses base 16. Your explanation is how it functions. Each hex digit represents a 4-bit nibble, and your link connects it right back to the scenario. Before we continue, subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, so remember, examiners aren't looking for short, disconnected labels. They want that Peel structure applied directly to the digital scenario. Building a strong theoretical foundation means actively training yourself to distinguish between nearby concepts, because confusing these terms is a frequent cause of lost marks. Look at memory versus storage, or validation versus verification. Let's do a quick interactive check right now. I'm going to give you 30 seconds to spot which student's answer follows the Peel framework when asked to explain the use of hexadecimal in memory dumps. Alex writes, a memory dump shows the contents of memory. It uses hex because binary is too long. Memory is RAM and storage is a hard drive. Sam writes, hexadecimal is used in memory dumps to represent binary data. Point. Since one hex digit perfectly represents 4 binary bits, evidence. It significantly reduces the number of characters displayed on the screen. Explanation. This allows developers to trace errors in the RAM much faster without misreading long strings of ones and zeros. Link. Time's up. It's obviously Sam, right? Sam finally used the Peel framework. Alex just dumped facts and confused memory with storage without linking it to the context. You have to train comparison just as much as single topic explanation. Now let's explore section 2, the method mark strategy. This maps out the exact discipline sequence examiners are looking for in your written answers. This is the transformation phase. We are turning those red pen marks into green check marks right now. By following this 4-step path, you methodically build an answer that captures every available method mark. This is the computer science success blueprint. Step 1, identify the exact requirement of the task. What is the command word asking you to do? Step 2, classify the relevant data or hardware. Are we talking about a MAC address, an IP address, or an HTML color code?
Step 3, explain the process sequentially. Walk the examiner through it step by step. Step 4, connect back to the context. Let's do a 60-second rewrite attempt for Alex. The question is, explain why HTML uses hexadecimal for colors. Alex originally wrote hexes 0 to F. HTML uses it for colors. 0 marks. Let's apply the blueprint. Step 1, the requirement is an explanation. Step 2, the data is HTML color codes. Step 3, the process. Each color, red, green, blue, is assigned an 8-bit binary value, which is converted to a 2-digit hexadecimal number. Step 4, the context. This allows web designers to easily specify over 16 million colors using a concise 6-character code like #FF0000 for pure red, minimizing syntax errors in the CSS. Boom, full marks. That's the difference the blueprint makes.
Specificity is everything. If a question provides a specific setting, like a school network, an embedded system, a robotic environment, a security incident, or database management, your sequential explanation must remain strictly anchored inside that scenario. If the paper mentions a school network router, you must explicitly talk about how hexadecimal represents the MAC address burned into that specific router's network interface card. You can't just talk about generic computers. You need to say, the network administrator at the school can use the hexadecimal MAC address to set up MAC address filtering, ensuring only authorized student devices can connect. You are plating the meal perfectly for the examiner. Real-world transfer matters immensely. Welcome to Section 3, Principal Examiner Warnings, where we navigate the minefield of Cambridge exams. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's get into these direct warnings from the principal examiners. Let's start our interactive workshop. We are going to look at these classic wrong turns. Challenge 1, data scan. We're putting a complex computer science data source on screen. You have a 60-second visual countdown timer. Imagine you are looking at a hexadecimal memory dump from a crashed program. What's the core trend? It's organized in rows, right? Each row has a memory address, followed by the hex value stored there. If you use vague wording here, like it shows the data, you lose the mark. You have to specify it displays the contents of specific memory addresses in hexadecimal format. Challenge 2, find the flaw. I'm going to show you a flawed sample paragraph from Sam. Read this. Hexadecimal is used for IPv6 addresses. A router is a device that sends packets. Hexadecimal is an advantage because computers process it faster than binary. Did you catch the flaw? Take a second. Yes, it's that last sentence. Examiners hate it when you give an advantage without stating the real reason, or worse, give a completely false reason. Computers do not process hexadecimal faster than binary. Computers only process binary. Hexadecimal is strictly for human readability. Naming a device, like a router, without explaining exactly how it uses the hex IPv6 address to route packets to a specific node is a classic wrong turn. To actively avoid these errors, implement this 3-pass revision cycle. Pass 1, secure your definitions and contrasts. Pass 2, rehearse worked explanations. Pass 3, practice exam adaptability. This brings us to Challenge 3, speed writing. You have 30 seconds to mentally draft one perfect PEL paragraph explaining the advantage of hex in assembly language. Ready? Go. All right, time is up. Did you hit the points? Point. Hex is used as a shorthand for assembly language mnemonics and memory addresses. Evidence. Machine code is pure binary, which is incredibly long and prone to transcription errors. Explanation. By using hex, programmers can group binary digits into nibbles, creating a much shorter, more manageable string of characters. Link. This makes the debugging process in low-level programming significantly faster and less prone to developer fatigue. That is how you layer your understanding for maximum adaptability. Let's move to our final section, Section 4, the reliable memory structure. This is your ultimate tool for exam day. Here is the complete computer science answering system. Before submitting any answer on hexadecimal representation, make sure you can explicitly answer these 4 core prompts. What is it? How does it work? Where is it used? And why is it better or worse than the alternative? If you want to guarantee top marks, you must follow these 3 rules. Rule 1, command word decoding. Always start by identifying if you need to state, describe, explain, or evaluate. Rule 2, Peel framework application. Never just dump facts. Point, evidence, explain, link. Rule 3, the time management matrix. Generally, it's 1 minute per mark. If it's a 4-mark question, spend 4 minutes crafting that perfect 4-step Peel paragraph, and then move on. Do not overwrite. This structure ensures your response is bulletproof, hitting every single criteria the examiner has on their marking scheme. Let's look at this critical piece of examiner feedback.
Students often know the theory but lose marks because they do not anchor their explanation to the details provided. Your theoretical knowledge is practically useless if it isn't tethered to the specifics of the question. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. You have to practice taking your raw ingredients, cooking them with the peel framework, and plating them perfectly for the specific scenario the examiner serves up. I'll leave you with this final thought to test your true mastery. If the examiner changed the scenario of your perfect answer from a smartphone MAC address to a banking system error code, would your explanations survive? Are your explanations robust enough to survive a total change of context, or are you just relying on memorization? Next time you practice, swap the context yourself. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.